Three students are there. Okay. So if I'm talking here is that is matter around us pure? If I'm talking, is matter around us pure? So the question comes from this chapter, from the name of this chapter, is matter around us pure? Pure. When you think about the purity of something, what do you I think that click in your brain is that something pure means like a water which is filtered. If you add some impurities like mud to it, it will become impure. Okay, like you are just going to get milk. So milk, if someone add, if it is from the direct buffalo, it is pure milk. If someone add it, so it is impure milk. Add water to it is impure. Or you can say that mud water is impure. Okay, but even if I'm saying that in terms of chemistry, even if you have milk which is directly blown from the cow, nothing is added, still it is impure, like in terms of chemistry, impure substance. Are you saying something, Sarah? Your mic is mute. So what I'm saying here is that anything pure or impure definition is given by in terms of chemistry is that as if a substance consists of two or more substance made up of two or more substance which are not chemically bonded together. Or in simple words, we will say that pure substance are those substances which consist of only one kind of particles. One kind of particles or atoms or molecule. Particles means atoms or molecule. We're just going to study. In the previous chapter, we have studied that the matters on the basis of their physical composition or the arrangements of particles of matters like solid, liquid, and gas, and their change in state we have studied. In this chapter, we're going to study matters in the other two states, other two forms. We have categorized all the matters into two parts broadly. One is a pure metal, other one is impure metal. Pure and impure. If I'm talking about the pure substance, what are pure substances? Pure substances are those substances that consist of only one kind of particles. What does it mean? One kind of particles. One kind of particles means, do everyone have the copy right now? With chemistry copy? Is there anyone? So you could keep in mind, okay, you have to make the proper notes. So what I'm saying here is that particle, first you need to understand the particle, the concept of particle in terms of chemistry. Like for example, if I'm saying if you have a strip of iron, and it consists of pure 99.99%, it consists of pure iron. Okay, and it is consisting of all same kinds of particles. Same kind of particle means same kinds of atoms if I'm talking. So we'll say that it is pure substance. It is pure substance. Like if you take the strip of iron, okay, and you have this strips, and in this strips, you have, this is the pure atoms of iron. Like I'm talking about that, these are the pure substance of iron, okay? Got it? So they will be considered as pure substance. Understood? If they are consisting only of same kind of particle, it will be considered as pure substance. But for examples, if you melt this iron or something and you add the carbon atom to it. Let's suppose you add carbon atom because they are having space. So you add carbon atom here. Let you add carbon atom in this state because the size of the iron atom and the carbon atom as comparison to the iron atom is very small. The size of the carbon atom is very small. So it can come into the intermolecular space here. Here is carbon atom. Now it is not chemically bonded. It is not chemically bonded. We are just fitting something. Like for example, you have a bag, you add your clothes in that bag, you add your notebook in that bag. So that is an empty space where you're just putting that. They are not physically bonded. Sorry, not chemically bonded. You are just adding the carbon atom to the interstitial space where it is vacant space where there is, so you are just adding that one. So now because you have added some different kinds of atom into it, into this one, it is not pure substance. It is considered to be as impure. It is now impure. But if has only one kinds of atoms, only iron, no carbon atom is added, then it is pure substance. Now coming to the point here is that the very important point here is that you need to understand that water is made up of two different kinds of particles, which is hydrogen and oxygen gas. Hydrogen and oxygen gas, when they chemically combine together, they form water molecule, a water molecule. Okay. Like for example, there are two hydrogen atoms here, one oxygen atom here, there's one oxygen molecule here, and two another hydrogen molecule here. They broke, their bonds are broken, and they are forming the two new water molecules. They are forming the two new water molecules. They are forming the two new water molecules. Okay. Now what you need to understand here is one thing, that this hydrogen atoms are chemically bonded with the oxygen atoms. Do you think that if I'm saying, like, what is the difference between the chemically bonded something? How can we recognize whether something is chemically bonded or not? Like you see that you take a glass of water, you add some sugar to it. Now you take a sip of that one. How you feel the taste? Tell me. Anam, you tell me how you feel the taste.
So can you repeat?
I'm saying that you take a glass of water, you add a tablespoon of sugar to it, and you dissolve it. You take a sip of that one. How will you feel the taste? Will it be salty, sweet, or will same? Will it remain same?
Since we have added sugar, it will be sweet.
It will be sweet, simple. Here you see that the constituents are showing their property after they are added to different substances. Okay. So this means these are physically bounded. These are physically bonded. Even though if you add some tablespoon of sugar, then you add some salt to it, it will start showing the taste of both sweet as well as salt. You add lemon to it, it will show the taste of all three: salty, sweet, and sour, lemon. Okay, and will become a lemonade. So they are showing their properties. They are showing their properties after the change, and they don't have fixed ratio. They don't have fixed ratio. Like you add a tablespoon of sugar to a glass of water, it will be a salty water. Sorry, sweet water. You add 2 tablespoons of sugar, it will be. But can you think that, can you imagine that water, like some people start saying that, no, we have found a different kinds of water. It is very energetic water. We have different, very high purity water. It has 3 oxygen atoms and 1 hydrogen atom, which is very beneficial for health. No, it will be rejected. Whether you take a drop of water from ocean or you take the drop of water from the sewage. If you take a water from RO, if you take a water from river, pond, anywhere, you filter it, you will find that every water molecule is going to consist of 2 hydrogen atoms and 1 oxygen atoms. They have fixed ratio. The 2 hydrogen atoms and 1 oxygen atom is going to combine. They will form hydrogen water. It will not like this. 2H2 plus O2 will gives you H2O2. It is not like this. It will be rejected. And one important thing, whether how can you recognize whether something is chemically bounded or not, that in this case the constituents are not going to show their property. Constituents are not going to show their property. Like for example, you see that hydrogen gas burns, it is a fuel, and oxygen help in combustion. But do water is showing this property? Do you think that water is combustible? I think that is carrying mixture of hydrogen gas as well as oxygen gas. One is fuel, another one is helping in the combustion, so it will instantly catch fire. But do you think that even if you pour the water on a burning fire, it will let it to extinguish? So here the hydrogen is not showing its property, oxygen is not showing its property. Water is going to have its own property, its own melting point, its own surface tension, everything is different. So even though the water is made up of 3 different kinds of particles, or 2 different kinds of particles, one is hydrogen, other is oxygen. They are made up of this three different kinds of particles, even though it's okay. But we'll consider as a whole H2 as a one molecule, because in this the constituent are not showing its property, and we'll consider it as a single particle. Will consider as H2O as a single particle, whether it is made up of 3 different kinds of substance or 2 different kinds of substance. They are chemically bonded and they're not showing their property, it will be considered as single particles. Okay, now you understood what is the difference between a particle in a pure and impure substance. Like I'm saying that hydrogen gas, it is made up of H2. It is a particle. It is a molecule. H2O is also a particle. H2O is particle, means one molecule of H2O is also considered to be as a particle. Why? Why we are saying that it is not a particle? It is made up of two different hydrogen and oxygen atoms. Just because here the hydrogen and oxygen are not showing their property. Like for example, a car and a steering, we'll say that a body, okay, a car and a wheel, okay, they are making a single entity which we called it a car. It is carrying wheel, it is carrying steering, it is carrying seat. But it is the whole combined quantity is known as a car, which will be considered as a single piece. Okay, got it? Same thing is in the water, because in the water, the hydrogen and oxygen atoms are combined together in a fixed ratio by mass, and they are not showing their property. That's why they will be considered as, how they will considered? Tell me. Will be considered as pure substance because it is chemically bonded. But if something is physically bounded, it shows the property after the chain, like you are adding a table of spoon of sugar into a water, it will be going into the intermolecular state and there will be physically bounded. Okay, you understood now concept? Understood? Yes or no? Sarah,
Yes,
Sumaya, Bhati, Anam,
Yes,
Anand,
sir.
everyone.
sir.
Understood?
Yes,
Yes.
Heather and Saad.
Yes.
Saad, you never
Yes.
ask the questions, okay? You understood the concept? Why were you absent in the previous class? You there? Saad? Okay, so dear students, please note each and everything that is on the screen. Okay, please note it down and please answer me. Saad, you have to answer each and everything by having your mic on mute and please turn on your camera. Okay, write each and everything that is written on the screen, dear students. Everything.
Sir,
Yes,
sir, I already written those.
there. I have written physical composition. Physical composition. Okay, and matter occupies space and has mass. Chemical composition, pure and impure substance. Then we have pure substance is one which is made up of only one kinds of atoms or molecules. Note it down. Yes, you noted everyone? Hanan and Heather, where are you gone? Noted?
Yes, sir.
Yes, sir.
Up to here. Bharti, you done? Slow writing. Sami and Sara, you also?
Sir, I completed.
Yes, sir.
Okay. So here we are just going to okay. Now, if I'm talking about the elements, there are different things, elements and compounds. Elements are the pure substance that consist of only one kinds of particles. Like for example, you take the strip of iron. Okay, and this is going to have means we're not saying particle. It will be best if we say atoms. Only one kinds of atoms. Like in water, there are two different kinds of atoms, like hydrogen and oxygen. So we'll say that it is not a element. It is a compound. It is a compound. Element is like sodium, like calcium, like magnesium, like iron, like tin, like lead, like hydrogen, like oxygen, like nitrogen, like fluorine, neon, argon, krypton, hydrogen, okay, tungsten. These are elements. We call them element. We call them element. Understood? We call them element. So element means, what do you mean by the word element? It is that consists of only one kinds of atoms, and you need to consider this one, that the atoms of different elements are different. Otherwise, if they have same, like for example, we'll simply say that like a human beings, okay, different human beings have different face, okay, they have different face design. So we'll say similarly, elements are those substances that consist of only one kinds of particle, one kinds of atom, and different elements have different atoms. Like for example, hydrogen atom is like this, only one electron. Carbon atom is like this, that is two in the first shell and four in the second shell. We're going to discuss this one in the next chapter, that is atoms and molecule structure. So just note it down, the different, that those elements that consist of only one kinds of atoms are called elements, and different elements have different kinds of atoms. All the atoms of copper element is same, but the atoms of copper and iron are different. That's why they have different, if they are different elements. Note this one. Noted everyone.
Yes, sir.
Everything
Yes,
needed. All the atoms of copper is same, but the different atoms of iron and copper are different. Got it? Sath, you noted? Are you facing any issue with the mic? Well, you keep your mic always keep silent. Sorry, mute. Again, you are just going to write. Sath, it's okay. Okay, you done everyone? Sumaya, noted? Sumaya, sorry, Samia.
Yes.
Okay, so let's move further. Now we shall be considering here that for example, if I'm talking about the just for example, I'm just showing you this is not the actual structure of gold atom. I'm saying that atoms of golds are different from atoms of sodium. And the atoms of copper are different from sodium, gold, every other element. Otherwise, if they do have the same, that it will be considered as same element. Like for example, if you find anywhere the hydrogen gas, so whether not in the how we will able to find out that the hydrogen gas is the sun is made up of hydrogen gas. How we comes to know this one? Because every element when burns or when it react or it burns, it shows some different type of you will say that a bar graph you can say. Okay, and there is every element the radiations that it release, it show different types of range radiations. Okay, so when we collect the radiation from of hydrogen gas, it is similar to that we receive from the when we burn the hydrogen gas, it shows some kinds of radiations. If we burn the sodium, so it will show different radiation as comparison to that of hydrogen and other element. Every this is considered to be as blueprints of every other elements. Two different elements when they are burned, they show different that you will going to study in the high classes. Different blueprints means we can say that different kinds of radiation that we call the blueprints. So if you want to know whether the sun, nobody has reached the sun. Okay, tell you. But how can we know that it is burning hydrogen gas there? Just because the radiation that are coming, we trace that radiation, and these radiations matches with the radiations of burning hydrogen gas here on the earth. That's why we'll say that hydrogen consists of, sorry, sun consists of hydrogen gas. The same, the gold atoms are different from sodium atoms, sodium atoms are different from copper atom. But if I'm talking about the gold atom, whether it is gold from Russia, London, America, India, Europe, Japan, anywhere. If it is gold atom, whether it is not on the earth, if it is found somewhere on the Mars, anywhere, then still it will be considered as we'll consider it as gold, and they are really going to have the same characteristics. Okay, you understood right now? So now what you need to understood here, one thing is that what is the difference between an element and a compound, and what is the main difference between an atom and a molecule. So you can say that like you have a matchbox. Okay, if I'm simply say that if you are just going to have a tip of a just imagine the size of an atom, like all the human beings on the earth, we just consider them as a size of an atom. Just consider that all the human beings are having the size of an atom. Okay, then the tip at the very tip of an alpine, you see everyone, alpine. Okay, the very tip of the alpine, all the human beings can come, even though they very large amount of space will be left. That all the human being, you, me, everywhere, everyone can come on the tip. If we consider the size of an atom as a human being, then all the human beings can come on the very first tip of this one, of this alpine. So atom is very small. So practically an atom never exists independently. It is impossible to have an atom. You can have millions of billions of atoms, okay? You can have millions of atoms, okay? Got it? And atoms is a single atom is not practically possible. So even if you are going to have a single small piece of iron or an or gold, it is going to have millions or billions of atoms in it. Okay, like even if you have 18 grams of water or only 1 gram of hydrogen, 1 gram of hydrogen is going to have 6.022 into 10^23 atom. This is very big size. This number is very big. So if you can imagine that 1 gram, or we can say that 2 gram of hydrogen gas consists of 1 point, or we can say 6022, and then we have 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. This number is very big. Even sun is, if you measure the sun distance, it is 10^15 something from the earth. This 10^23. This number is very big. So just a 2 gram of hydrogen is going to have this number of hydrogen atoms. Can you imagine that how small an atom is? How small an atom is? An atom is very small. So it is practically not possible that you can have a single atom or a 2 atom or a 1 lakh atom. It is not possible. Atom, there is large number of atoms are present in a single. Okay. Now what I'm saying here is that, like, you take the drop of water. There are millions of water molecule in that one. Millions of water molecule. Like we are just making this water molecule like this way. Okay, so this water molecule H2O, we consider this one. Okay, this is a water molecule. So millions of such water molecules are present in a drop of, even drop is a very big thing. Even if you if you pin an oil pin in the water and you bring it back, even the touch part, the water that is stick with that oil pin, it is going to have billions of atoms, molecule in that one. Okay. Similarly, if you take the oil pin and if you cut its tip, the smallest tip, possible tip of the oil pin. It's your choice. Cut the smallest possible, as small as you can, even though it is going to have billions of atoms of that iron in that one. So one thing you have to keep in mind, that practically it is impossible that you are going to have a single atoms. It is not possible. So what is an element? An element consists of same kinds of atoms. So like, for example, you take this strip of iron. Iron is going to have same kinds of iron particles, iron atoms. So if I'm talking about this one, that what is compound and an element. An element is a substance that consists of only one kind of atoms. And a compound is that substance that consists of same kind of molecule. Compound, we can say that a compound is a substance that consists of we'll simply say that. What is a compound? An element consists of same kinds of atoms. And what is compound? So we'll say that compound consists of a compound consists of same kind of molecule. Same kind of molecule. Now you have to concentrate here, one important thing. A compound, the smallest possible particle of a compound is a molecule. Smallest possible particle of a compound is a molecule, because a compound consists of two different kinds of atoms, like water, H2O, like calcium oxide, like carbon dioxide. Okay, this consists of two different kinds of atoms. So smallest possible particle of an atom, of a compound is a molecule. And smallest possible particle of an atom of an element is an atom. An element is made up of numerous atoms. Numerous atoms. Same atoms. A compound is made up of numerous molecules. Compound, molecules, elements, atom. Because element don't have different kinds of atom. Element have same kinds of atom. Different element will have different kinds of atom. A compound consists of two different kinds of atom, chemically bonded like in water, two different kinds of. But this H2O is considered as a molecule. So first you understood the difference between an atom and a molecule. What is an atom? Atom is the smallest indivisible particle, which you know that what is an atom. According to Dalton atomic theory, just concentrate here everyone. Dalton says that when you keep on dividing something, a stage will come when it is not possible to divide something. And we call this as an atom. So he said that atom is indivisible particle of a matter or a substance. Or we simply say that of an element, the smallest indivisible particle, which can't be further broken. We can break the atoms into its subatomic particle that we're going to study in the next class. Sorry, next chapter. It is into electron, proton, and neutron. But it is not possible to break the atom in the chemical reaction. This is in the nuclear reaction, nuclear bomb. And nuclear reactions is different than the chemical reaction. Like there are some laws that are applicable in India. But if you went to some other country where the Indian laws are not valid, same thing. The laws of chemical reactions are not valid in the nuclear reaction, and the nuclear reactions laws are not valid in the chemical reactions. So there are different kinds of reactions, chemical and nuclear. So atom can be broken in chemical reactions, but atom is indivisible in the nuclear. Atom is broken in the chemical reaction. Can be broken in the atoms can be broken in the nuclear reactions, but it is not broken in the chemical reactions. We can't break the atom in it. So first note the definition of an atom. Then we're going to discuss it further. Note it down. An atom is the smallest indivisible particle of a substance. Note it down. Noted, everyone? Noted? This one, yes or no?
Yes.
Now,
Yes, sir.
now, if I'm talking about the molecule, what is a molecule? Molecule, you check that when two or more different kinds of atoms, they may be different or similar, but they're two different or similar. The two atoms are chemically combining. Okay, so what I'm saying here is that when two or more similar or dissimilar atoms chemically combine together, they form a molecule. Note it down. They form a molecule. that I'm going to show you, explain it with the help of a video. So just try to understand this concept, okay? Just a minute. Is this video screen is visible to you now? Yes or no?
Yes, sir.
Let's learn the difference between an atom, a molecule, and a compound. Welcome to Moo Math and Science. The smallest unit of matter is called an atom. Each atom is made up of smaller particles known as subatomic particles. In the nucleus or the middle of an atom are two subatomic particles called the proton and the neutron. The positively charged particles in the nucleus of an atom are called protons. The number of protons in the nucleus is the defining property of an element and is referred to as the atomic number. The uncharged particles in the nucleus are called neutrons. Orbiting the nucleus of an atom is a cloud of negatively charged particles called electrons. The electrons are much smaller in mass than the protons and neutrons. The mass of an atom is based on the sum of the mass of the protons and the
That you
neutrons.
understood. Everybody in the class, is there anyone who is facing difficulty in understanding the Hindi? Everyone understood Hindi? Is there anyone who can
No, sir.
I don't, sir.
I don't understand.
who don't understood? Name? Saad. Saad don't understood Hindi. Okay, so let me explain you. I'm going to explain you with the help of let me explain you.
A molecule
Let you understood with this one.
is when you take
You understood this one again.
is based on the sum of the mass of the protons and the neutrons. A molecule is when you take individual atoms and physically connect them together. The atoms are stuck together by either sharing the electrons, which is a covalent bond. A molecule like ozone can be two or more of the same atom. Another example is when you stick two hydrogen atoms to one oxygen atom, you get water. In addition, you have compounds. A compound occurs when you combine elements together chemically. But for it to be a compound, these elements must be different. An element is a pure substance consisting of only atoms that have the same number of protons. Chemical elements cannot.
What I'm saying here is that what he's saying here is that when the two different kinds of elements combine together chemically, they form a compound. When two different kinds of atoms chemically combine together, okay, they form a compound. So for forming a compound, there must be two different kinds of atoms. Okay, and they should be chemically combined together. Like for example, if I'm saying that H2, if I took the example of H2, let me show you this one here. Okay. So if I'm giving the examples here, okay. Let's suppose if I'm taking that two different or similar kinds of atom chemically combined together, like if I'm having hydrogen H2, why the hydrogen exists in the form of H2? Oxygen exists in the form of O2 in nature. Not a single atom exists. So this is a different thing that we're going to study in the next chapter. But here, that two same kinds of atom, like HH atoms combined together, they form H2 molecule. OO atom combined together, they form O2 molecule. N2, nitrogen exists in the form of N2. So they combine together, they form N2 molecule. But these are the molecules. These are the molecule. But these are the molecule of an element. These are the molecule of an element because they are similar. Okay. Got it? They are similar. Hydrogen, hydrogen, oxygen, oxygen, nitrogen, nitrogen. So these are the molecule of an element. Molecule of element. But if I'm saying that water, the two hydrogen atom combined together with oxygen atom, okay, H2O, carbon dioxide, one carbon atom combined together with two oxygen atom, it is CO2, it is carbon dioxide. Okay, and are you getting this one? So water, carbon dioxide, Next, if I'm taking NO2, nitrogen dioxide, one nitrogen atom and two oxygen atom combined together, they form NO2. So they are the two different kinds of atom, like hydrogen, oxygen, carbon and oxygen. Okay, sodium and oxygen, sodium and nitrogen and oxygen. Okay, so these are the two. So they will say that these are the molecules. These are also molecules because two different kinds of atoms are combining together. What we wrote in the definition: when two or more similar or dissimilar, when two or more similar or dissimilar kinds of atoms chemically combined together, they form a molecule. Now the molecules are of two types. When they are similar, it is called homoatomic molecule. Homo means same. Homoatomic molecule. When that is dissimilar, we call hetero. Hetero means different. Heteroatomic molecule. But before hetero and homo, you need to understand that if the same element atoms are there, then it will be the molecule of an element. And if there are different atoms are there, then these are the molecule of a compound. Molecule of a compound. These are the molecule of a compound. You understood, everyone? Yes or no?
Yes, sir.
Understood? Molecule of a
Yes, sir.
compound, molecule of an element. Okay. So that if different atoms are there, then it will be the molecule of compound. If the same elements are there, it's the molecule of an element. Okay. Got it? What is an element? Consisting of same kinds of atoms. Like here, H2 is also an element because it is consisting of hydrogen atoms. Or O2 is also. The N2 is also. Okay. And similarly, what is a compound? The atoms, the substance which consists of two or more different kinds of atoms chemically combined together. Like you see, different kinds of atom chemically combined together, it is a compound. So it is a molecule of a compound. If we take this one H2O, so we'll say that it is a molecule of a compound. If we take only H2, then it will say it is a molecule of an element, which is hydrogen. Understood? Yes or no? Understood, everyone?
Yes, sir.
Yes.
So now, and how can you define? Like for example, if I'm saying that here it is H2O is a molecule. Like if I'm taking this iron atoms, like in steel, if I'm talking steel, like you see that, let me explain you this thing also properly. Like for example, we have this atoms, okay? Got it? We have these atoms of iron. Iron atoms are bigger in size than the carbon atom. We find that when the heavy load is done added to this railway track, we find that there is a distortion or these iron atoms get slided. We find that the first layer can slide over the second layer easily, and it come here. Like you see, it is here like this, but this layer slide and comes here like this way. This is called distortion. Distortion in atoms. Atoms layers are sliding. Because of that, it may result in distortion or bending of railway track. So what we do here is that in order to prevent it, we add 1 or 2% of carbon. Where does the carbon atoms goes? Carbon atom goes into the intermolecular space between them. So carbon atom goes here. Here carbon atom goes. So when the carbon atom goes into the intermolecular space or interstitial space, then this layer cannot slide, and it strengthens the atoms. Sorry, the iron. It has become more durable. Heavy loads can be used over it. Now it is not distorting shape. So this we called steel. There are two kinds of steel. One is stainless steel. Another one is normal steel. So when we add iron with 2%, iron 98% and 2% carbon 2%, then it forms steel. Not the stainless steel which we have the utensils in the home. Like the railway track. Railway track is made up of steel. Why it is made up of steel? Because we need to run the heavy load over these railway tracks. They don't. It should not go. It should not go. So that's why We use railway track. Now, what is the main thing that we need to understand here is that this iron, okay, 98% with 2%, but it is not a compound. Why it is not a compound? Why it is not a compound? Because in this, the carbon atoms are going into the intermolecular space. They are not making bond. Okay, here the carbon and iron are showing their property. But in case of water, the two H atoms are chemically combined together. Here the hydrogen atom and oxygen atoms are not showing their property. Okay, so it is, we'll simply say that here one thing, that now you understood the concept between the atom, a molecule of an element and a molecule of a compound. Now you understood the difference, main difference between the compound and the we'll simply say that the normal mixing of something like a tablespoon of sugar added. Mixture, we can say simply say compound and mixtures. Are you getting? So let you understood the difference between compound and mixtures first. Have you noted this one? When two or more similar or dissimilar items chemically combined together.
Yes,
Okay.
sir.
Okay. Let's you write the difference first. Compound and the mixtures. What is the main difference between compound and mixtures? An element in a compound, elements are chemically combined together in a fixed ratio by mass. What do you mean by this? Simply we say that two hydrogen atom should combine with one oxygen atom to give H2O. You cannot say that no, we have good quality of water. We should have two oxygen with two hydrogen atoms. No, it is not so. For every two hydrogen atom, there must be one oxygen atoms. Okay, we'll discuss this one in detail. But in mixtures, there is no fixed ratio. You add one tablespoon of sugar to the water. You add half tablespoon of sugar of water. It will be a water. Okay, so in a mixture, there is they are not combined together in a fixed proportion by mass. No proportionate manner is there. Compounds, in the compound, the constant do not show their property. Like in the water, the hydrogen and the oxygen do not show their property. Don't show their property. But in the mixture, you see that the hydrogen, in the mixture, that the water and the salt, they both show their property. Salt has a taste of sweetness, salty. It gives a taste of salty. When you add it to water, it is still going sugar. It is showing its property. The constant in mixture show their property, from which the mixture is made up of all the ingredients that is added when making a mixture. They show their property. But in compound, it does not happen. Like in water is made up of hydrogen gas and oxygen gas. Hydrogen is a fuel, oxygen help in combustion, but water never burns. It is not showing its property. The third thing, that the constituent can't be separated, like you see in a compound, because they are chemically bonded. So when you heat it, ice get converted into liquid water get converted into vapor, but it is still water. You can't separate the hydrogen gas and oxygen gas by simple filtration, by evaporation, by boiling, by freezing. You cannot separate it. But in mixtures, if you take water and salt together, a mixture of water and salt, you heat it on the low flame, you'll find that all the water will get evaporated and salt will remain in the beaker. Like, have you seen this one? When during the, you have not seen this one. But if you have seen that in India, where water quality is not good, like in Agra, you heat that water from the Agra, you will find that even though the white color substance remain in the on the beaker and the water get evaporated. These are the impurities that are dissolved in the water. They will remain and the pure water get evaporated. So in a compound, We cannot separate the constituent by simple physical method, but in mixtures, we can separate them by physical method like filtration, distillation, evaporation, boiling, crystallization. We can separate the mixtures. Got it? Like sand and iron mixed together, they form a mixture. But you can separate it by magnet, iron nail. But if the iron is mixed with some compound like oxygen, can you separate the oxygen from that one? No. It's not possible. Okay? So they can be separated only by chemical method, but here it can be separated by physical method. They have fixed formula, like compound have fixed formula, like H2O. Whether you take the water from anywhere in the world, whether you take it from the ocean, whether you take it from the river, or not only in the world, if you find the water on the moon, it must have H2O. The same formula, H2O. You cannot say that for India, for the earth, water has formula H2, and for the moon it is going to have H3O. It is not possible. Water means water, it must have fixed formula H2O. You cannot change it. Why we can't change it? We're going to discuss in the next chapter. Okay. So they have fixed formula, fixed melting point and boiling point, but there is no fixed formula, no melting point, no boiling point is there in a mixture. Got it? So have you noted this one, dear students? Noted?
Yes, sir.
The mixture between compound and this one, you have noted?
Yes, sir.
Okay. So that's all. If you have done this one, then we're going to discuss in the next class. And those who have not done, please take the screenshot and please note it down in the topic. Okay, because this is going to come in examinations.
Thank you, sir.
Okay, take care, everyone.
Thank you, sir. Take care.
You too, beta. Hello, Mariam. How are you? Is I'm audible to you?
Yes, sir.
Yeah, wait for 2 or 3 minutes so that other friend may also join, okay?
Yes, sir. Sir, we got chemistry marks of the test.
What are you saying? Mariam, are you saying
Sir,
something?
we got the chemistry marks.
Of the test, how much you score?
Sir, I got 5.5 on 6.
5.5 out of 6. Okay, in the school,
Yes, sir.
in the physics, how much you got?
Sir, I only got chemistry. That's why I didn't send the. Our parents teachers meeting is not yet over.
Okay, okay, okay. So, Mariam, let's start. Okay. So let's revise something, Mariam, okay? Yes, I'm going to give you a question, till then you have to note this question, and then we're going to discuss
Okay,
in
sir.
detail, okay? Have you done that one? Just,
Sir, which question?
just